Welcome everyone to the part 2 of class imbalance. So first of all, we will see what are some of the resampling techniques. Resampling is a commonly used method for dealing with excessively imbalanced datasets. It entails undersampling, removing samples from the majority class and or boosting the number of examples from the minority class, which is better known as oversampling. So we have quite a few techniques for resampling. First one is smooth. The second one is random undersampling. And the last one we have here is random oversampling. So techniques for class imbalance of undersampling and oversampling looks like this. As you can see here that in undersampling, we take the samples out of majority class and make it equal to the minority class. And in oversampling, we make the copies of minority class equal to the number of majority class. The simplest implementation of oversampling is to duplicate random records from the minority class, which can cause overfitting. In undersampling, the simplest technique involves removing random records from the majority class, which can cause loss of information. First, let's understand what is smooth, and then let's implement this with the credit card fraud detection example. So what is smooth? Synthetic minority oversampling technique. Another method for oversampling the minority class is called synthetic minority oversampling technique or smooth. Many times, simply adding duplicate minority class entries to the model doesn't add any new data. In smooth, new instances are synthesized from the existing data. If we can explain it in simpler words, then smooth selects a point at random from the minority class and calculates its k nearest neighbor for this point. Between the selected point and its neighbors, the artificial points are inserted. How smooth works? So select a class of minority as the input vector. Then find its k closest neighbors. The smooth function takes the k neighbors as an input. Place a synthetic point anywhere along the line connecting the point under consideration and its selected neighbor. Then choose one of these neighbors. Continue doing so until the data is balanced. So smooth looks like this. As you can see that we have an original dataset here with the minority classes shown as green balls and the majority class shown as blue scales. So smooth generates the random samples by finding out the k nearest neighbors. And that's how the dataset is resampled, having equal number of majority and minority classes. So we have an example of credit card fraud detection, and the dataset that we are about to work on is imbalanced. Let's implement. First of all, I will open the Jupyter Notebook from here. Now I will open Introduction to Data Science plus Imbalance, and I will create a new notebook. First of all, I will rename the notebook by saying class imbalance part 2. Now, as we know that, first of all, I will be using a markdown for importing libraries. which is quite essential to do. So I will say import numpy as np, import pandas as pd. Then I will say from imb learn dot our sampling import smooth, and that is how I will import smooth. Now I will create another markdown and say read CSV. Now that we have a different CSV file, so I will say transactions equals to pd.read CSV, and the name of file is transactions.csv, which is separated by commas, and I will run it. So this dataset is quite large, which consists of thousands of rows, and that's why it's taking some time for reading the CSV. Now, I will say transactions dot head to see the first 5 rows of the dataset. All right, so we have the column set, type, amount, name or region, and new balance, and so on. And this is our target variable. As you can see here, the name is fraud, which consists of values 0 and 1. So 0 here means no, and 1 means yes, that a transaction is fraud. Now, I will generate a little more summary of the dataset by saying transactions.info. All right, so we have 5 float objects, 2 integers, and 3 objects. Now let's suppose I want to see the count for each of the majority and minority class in the column of is fraud. Then I will say class count 0 and class count 1 equals to transactions is fraud dot value counts. Calculate the value for these classes. Now I will say print class count 0, and similarly I will say print class count 1 to see the number of classes. As I can see that the transactions which are 0, or which represents that a transaction is not a fraud, is more in number. There are 63,43,476, and the transactions that are fraud is 7,770. We can do this in one more different way, and that is by separating each class. So I will say class 0 equals to transactions is fraud if it is equal to 0, then store it in class 0 variable. Similarly, I will say class 1 equals to transactions, and then transactions if is fraud column value equals to 1. Now I will say print class 0 dot shape, and similarly I will say print class 1 dot shape. As you can see here that the shape 0 is of 63,43,476 by 10 columns. And similarly, for class 1, the shape is 7,717 rows by 10 columns. Now let's use the function or the resampling technique of smote. First of all, I will create an instance of smote and I will say sampling strategy equals to minority. Now I will have to separate the target variable and the feature variable. So I will say x equals to cross-sections dot drop, and I will drop some columns like the target variable from the feature, which is fraud, and I will also drop type. Then I will drop name origin, and later I will drop name destination, and I will say access equals to columns. And similarly, I will keep only the target variable in y, which is fraud. Now, by using the smote variable, I will fit the resample of x and y, and I will store them in variables. For x, I will say x smote, and for y, I will say y smote. All right. Now, I would like to use the function of counter to count the values for y and y smote. So first of all, I will import the library by saying from collections import counter. Let's run it. Now I will get back and say print original data set shape, and I will use the function of counter and I will say y, and similarly I will say shape of dataset after resampling, and the shape is the counter of y smote. Let's run it. Now you can see here that the original dataset shape was of class 0 was 63,43,476, and for the class 1 it was 7,770. Now we have used the technique of oversampling in smote. So the shape of dataset after resampling is the same for each of the classes. It's same for 0 and it's also the same for 1. You can also do one more thing here by passing a parameter in the smote function. You can say random state equals to 42. Let's suppose. So random state is used to randomize the data. Let's run it. In fact, this approach is better to use. So this is how the technique or SMORT works. Now let's go back to slides. You might be wondering that which evaluation metric to use for an imbalanced classification. We have to choose a proper evaluation metric while dealing with an imbalanced classification dataset. A classifier's accuracy is calculated by dividing the total number of accurate predictions by the total number of predictions. This may be adequate for a class that is well balanced, but it's not optimal for the class imbalance problem. Other metrics include precision, which measures how accurately a classifier predicts a certain call, and recall, which measures how well a classifier can identify a class. F1 score is a better statistics to use for a class dataset that is imbalanced. It's harmonic mean for recall and precision. So here is your homework. This is the link of dataset, which is a classification problem. The tasks include do some exploratory data analysis, then find out the counts for each class in target variable. In the last, make sure the dataset is balanced by using SMORT. So this is the end of this video. See you next time.